For this question, we're doing part C of 2014, number 5. It says, write but do not evaluate an expression involving one or more integrals that gives the perimeter of R. So we're looking for the perimeter of R. So of course, it's going to be this blue part, this vertical part, and then the curve. Okay. So the first two parts are really extremely straightforward. This first part, for that, we know that this point is at 1, -2, and this point is at 0, 0. And so the length of that part is quite simple. That first part here, right, that first part here is going to be just the square root of 2 squared plus 1 squared, which is just radical 5. So this is just radical 5. Okay. And then this second part here, this vertical line here, of course, we know that this point here is the point 1 comma e to the 1. And so the distance from here to here would just be e minus -2. And so that distance would just be e plus 2. So the only real question we have is, okay, so what is the length of curve? And I like to think of length of curve in terms of distance formula again. So the length of curve is going to be the integral from a to b of the square root of 1 plus, and in this case it's going to be dy dx, quantity squared, and then times dx. And of course, if we took this dx and we put it inside the square root, then we would have a dx squared here, and you'd multiply with dx squared, so it would just be dx squared plus dy squared, which is distance formula. And so now we just plug in our values, and so our total perimeter is equal to radical 5 plus e plus 2 plus the integral from 0 to 1 of the square root of 1 plus, and then we need to find the derivative. So to find the derivative of that function, y prime, of course, is just equal to first times derivative of the second, which would be 2x e to the x squared, plus second times derivative of the first, which would just be e to the x squared. And we just take that and put it right here and square it. And let's just verify that answer is there. And that is, in fact, what the answer they have is. I think I've got it right here. First times derivative of the second. Yeah, I got it right here. The x squared stays in there. And so you can see you get 1 point for finding this derivative. So for knowing that you need the derivative inside of this formula, 1 point for having your integral correct. So really knowing this formula is basically absolutely vital for all three parts. If you don't know the formula for length of curve, you cannot get any of the 3 points for this problem.